all, thank you, Mr. Yamaki, for the opportunity you gave us to have an interview with you.
Thank you very much. It's my pleasure.
Okay. As I told you before, I have been to visit your wonderful factory in Aizu many years ago. And your father told me that everything in Sigma devices are produced in Japan.
Yes.
Is till now
the same.
You're the same.
Yes, especially in the middle of the 90s, Japanese yen get so much appreciated, got stronger. So the production costs get very high. So at that time, many companies offshored the factory to other countries like China or Malaysia, Thai. Actually, it was a big discussion in our side, but we decided to stay in Japan because Sigma is still family-owned private company. So of course, making the turnover big or making the profit big, higher is important. But the most important part is to keep the employment, to protect the employees. If we offshore the factory outside of Japan, we may have to lay off the people at the factory because we cannot double the production. If we have the new factory, we have to reduce the factory in Japan. But that is not what my father didn't want to do. So we decided to stay in Japan and change the product lineup. At that time, the majority of the products are entry-class products. Because of the high production cost, it was quite difficult to continue the business with that. So since then, we started to expand the production lineup to mid to high-end product.
But do you have advantages also in controlling production in this way? So.
Correct. First of all, especially lens, the lens manufacturing is getting more complicated. It's more and more difficult. So having the long experienced workers are quite important to produce high quality products. And also most of the we also do business with suppliers, but most of the suppliers are located in the local area near Aizu. So we can have a face-to-face meeting very frequently to make the products even higher quality. So this is quite unique for us. Today, most of the major companies have they say, global procurement. Global procurement, they buy the cheapest or low price parts from all over the world and assemble in one location. But we do everything locally, which is very unique compared to the modern manufacturing technology. But this is, I think, we strongly believe this is very important to make a high quality product.
We see that your products have reached a very, very high level. We tested recently your 50 millimeters f 1.4, the 35 millimeters f 1.4, and your zoom 1835 are wonderful.
Thank you very much.
I don't know if you have seen the charts, but
yes,
really impressive. And these lenses are in their category are the best lenses I ever seen. much better than Canon or Zeiss lenses. This is quite surprising. You are able to do that. Why you are able to do now these lenses and not 5 years ago?
Yeah. There are several reasons, mainly 3 reasons behind that. The first of all, now we have the environment is better for the engineering, for the high quality product engineering. We have more glass materials which never existed before, which help us to make the high quality products. And also computer become more powerful. So the calculation time for the ray tracing getting shorter and shorter. When I joined the company, optical engineer input some data and waited 20 minutes, 30 minutes to finish the calculation. But today, computer is so powerful, so he can continuously ray tracing for all days. So the cycle time of the ray tracing design is getting shorter. So we can, engineers can try many options. That's the first reason. But this is the same environment for all the manufacturers. Second is we are very fortunate to have very good engineers. We normally hire the students who graduate from college, university, and they know that Sigma is doing only for photos, not for other white goods or printers or copier machines or semiconductor business. They know that Sigma is only doing the photo business. That's why those who wants to do for photo business, who wants to design the lenses or cameras, they come to us. So these days, most of the engineers at Sigma are very passionate about photography, passionate about camera, and passionate about photography. They always think about 24 hours, think about the cameras and lenses. So such a passion helps for us to make good products. That's the second reason. But the biggest difference is, again, I think the factory, our factory in Japan. Their capability or their technology is quite high. They are very experienced. So they are very flexible to accept the design from the designers. Sometimes I heard that other companies, sometimes factory reject the lens design because it's too difficult. So if they accept a difficult design construction, the yield of the production gets lower. So it's not efficient. One of the optical engineer working at other company explicitly said to me that he envies Sigma engineer because our factory accepts such a difficult glasses, although it's quite requires high technology. So we are very fortunate to have such a good factory. It helps a lot to make a high quality product.
Sure. And you talk about difficult glasses. Which are the difficult glasses? You say, I know that you are using now the FLD glasses. Is this a difficult glass?
Yes, FLD is one of the difficult glass. FLD, or we call it SLD, special low dispersion glasses. These are relatively soft compared to the traditional normal glasses. So very careful attention for the polishing is very important. it's easy to have a scratch or digs in the surface of the glass. So, however, at the polishing department, many people working. So all of them must pay very careful attention for the polishing. If the one less careful worker makes some error, many glasses we have to reject many glasses. So in this case, yield get lower. It's just one example.
It's the same problem there is with fluorite. It's a soft the surface of fluorite. So I know usually is never placed in the front lens.
Yes.
And what's the difference between FLD glass and fluorite?
In characteristic wise, it's very similar. I can say almost the same, but the way of the recipe of the making the glasses is different. That's why the cost for the glass are significantly lower than the original fluorite glass.
Another special particularity of Sigma lenses is that they are tested. Each lenses you say is tested with your MTF A1 system.
Yes.
Why you decided to do that?
Because we want to make every single customer happy. So once we have the good design optics, we want to make sure all the single lens have a high quality. So we wanted to test every single lenses.
But this is a real problem, or if that you won't guarantee the customer that you have tested. I mean, why other companies don't do that?
I don't know what other companies are doing, but it's not so challenging for us. The challenge, we just take time to inspect each lenses at the assembly line, at the end of the assembly line. So it adds some cost. But the most challenging part is the development of the MTF, our dedicated MTF measurement instruments, and make the inspection time as short as possible. This was quite challenging. When actually even before A1, we had our own dedicated MTF measurement instrument. But this measurement machine used a normal Bayer sensor, sensor. And the resolution of the sensor was not enough to inspect the very high quality lens. But at the time, such a high resolution sensor was not available for the industry. And in the meantime, we about to release SD1, which has a very high resolution, and Nikon was about to release a D800. So we need to release a lens which can be usable for SD1 or D800, but our testing machine is lower resolution, and we had a problem how we can inspect the lens. Then we understood that we have very high quality, high resolution sensor, foveon sensor. So we decided to develop our own dedicated MTF machine using foveon sensor. This is very unique, so it was quite challenging. But because we make a camera, so we know the how to process the images to test the lens. So I think that our engineer did a great job. And also, in order to use it at the assembly line, the testing time must be as short as possible. It's not a laboratory or it's not a research. So the time is very important. So they did a very careful investigation, research, to make it short. Mm.
Again, it is not a greater cost for you because you can say other way to test the lens at the end, so you can have in short time you can understand if the product is correct.
Yes, the interface of the measurement instruments is quite simple. We designed so that everybody can use it. Just operator attach the lens and press the button, and then the machine let the machine inspect the lens, and the machine tells good or not.
Okay. Well, what about future lenses? I know you presented want to present 150-600 lens. You have two versions
yes.
of that lens. Why two versions?
We started this project as a replacement of our existing 150-500. And the main purpose, the goal of this project is to change the spec, because if we stay the same 150-500, we make a very similar lens. So we decided to go to 150-600. And during the study of the optical design, we backing to the original. So for this project, we set the goal, implement a very high quality optical performance, but we wanted to make it very compact because our current 150-500 is very relatively compact for 500mm lens. So we set the two goals. But while we are studying the lens design, we found that the chromatic aberration in the corner is quite difficult to control. It's not a huge problem, but if stay in the very compact size, we may have to compromise a little bit with chromatic aberration in the corner. And we have a very intensive discussion within the team with engineers. And when engineer concluded, in order to suppress the chromatic aberration, we have to make it big. But in this case, we cannot make a compact, lightweight telephoto zoom lens. Then I thought about the project many times, many days. Maybe I was thinking about several weeks, 2 weeks, 3 weeks, and I concluded, let's separate this project into two. One is to implement the best image quality, even at the chromatic aberration. And one is take balance between the optical performance and size and weight and cost. Actually, if you look at the center of the performance, there is not so much difference between the two versions. You can see the difference in the performance only in the corner. The chromatic aberration in the corner is quite significant. So for Sigma, I like to those who care about the quality truly, I wish them to choose the sports version. Those who want to have a well-balanced version, he should choose the contemporary version.
you know that actually with digital cameras you can correct
yes.
aberration, chromatic, lateral chromatic aberration, distortion, and so
yes.
on. Do you think that is a good way to have this aberration in your lens and let the camera correct them later?
I agree. That's one of the options and one of the good technology to achieve the high quality in the image. But I still strongly believe it's very important to convey the very good optical image, the high image quality from the lens. First of all, as a Sigma, we are the third party supplier. So such a correction is not implemented automatically in the camera. So customers have to correct with software afterwards. So maybe some customer may not like to do it. That's one of the reasons. The second, the life of the lens must be longer than camera. Now, camera is a pure digital devices. DSLR combined many mechanical parts, so it's a combination of the analog and the digital devices. But basically, it's a digital device. So digital life of the digital device is shorter and shorter. The camera will be a kind of device to be replaced every 2 or 3 years. But the lens, the life of the lens is much longer than camera. So if the customer use the lens with a higher resolution, but the lens have to be usable with such camera. So providing the highest image quality as possible with the lens is still important for the future, because the lens is a very important asset for the customers. I think in the future, the lens will be, in a sense, not 100%, but in a sense, lens is become a more important device than camera, and has a much longer life than camera. So we pay more attention to the quality.
I know that the most important part of your production is for digital SLR cameras.
Yes, yes.
And what about mirrorless? I've seen you support Micro Four Third and Sony E cameras. But what about Fuji, Nikon 1, Canon M? Do you plan to support also these cameras?
First of all, I think the mirrorless camera is a very promising product for the future. So as a Sigma, we plan to, we never give up expanding the product lineup for the mirrorless camera. We always plan to expand the product lineup for the mirrorless. So if there's opportunity, we like to support as many systems as possible. But I think it's the one of the important mission for the lens manufacturer. Supporting as many systems as possible is very important. But also our resources is limited. Our engineering resources is limited. We have many things to do, many projects to make the product even higher quality or to make the production more efficient. So supporting the new system is quite time consuming and requires lots of engineering resource. So we have to carefully select who is our customer. Again, Sigma is now making our lens only in Japan. Production cost is high. So we define our main customer is a photo enthusiast, those who like serious photographies. So we probably expand our product lineup for probably those people, maybe who uses a mid to high-end mirrorless camera. They are our main customers, I think.
But also in the mirrorless, with mirrorless cameras, you see. Also, there are high-end photographers using mirrorless cameras.
Yes, yes.
So you plan to support these cameras?
Yes, yes. That's the plan.
You have a wonderful service that is a mount conversion service.
Yes, yes.
There are many photographers using that. How many lenses are you changing usually in a year?
How many people are using our system camera? So far, I cannot disclose a number. So far, very small number of the people are using this system, because we provide this service only for our new series lenses, art, sports, and contemporary. So not so many. We don't have so many product lineup, and relatively new. So those lenses are very new. So very small number of the people are using right now. But in the future, I think more and more people use that service. We started this service. We came up with this idea because I found that some photographers switch the system from A to B, B to A, or some photographers use multiple system. Canon system, Nikon system, Sony system. This is a relatively new trend, I think. In the time of the film camera, 20 or 30 years ago, photographers are very loyal to one system and they continuously use it. But these days they switch one to A, B, to another to one. So I think again we want the customer use the lens as long as possible. So we decided to provide this service.
I like it.
Thank you.
Well, there are technologies that you think will be important to develop lenses in the future, not new technologies. I say where we can expect something new in glasses, in new material with nanotechnologies. I don't know, or new method to produce spherical lenses, or new method to mechanical work to mount lenses. Where new technology you think we'll find in the future?
Of course, we are always working very hard to introduce a new technology, and without such a advanced technology, we cannot make a high quality products. In the future, I think that making the high quality lens will be more and more difficult, because the camera probably have a more and more resolution, higher and higher resolution, and because of digital devices, I think that most of the camera manufacturers can do that. They can implement higher resolution. But when it comes to lens, it's quite different story, because it's analog devices. So it's not, we can make a huge jump to the higher quality. So we have to introduce a new technology. New technology is not, in my opinion, is not something totally different. It's not revolution, but the evolution based on the existing technology. Much tighter tolerance, much careful attention to the polishings, much higher precision. These new technologies are very, very important to make a high quality product.
So not completely different new technology that change completely the way you construct lenses, much smaller progress.
Yes, that's my understanding. It's at least for some coming years. These days are some good advantage in plastic lens. There are many plastic glass lens material, plastic material, which has a very unique index. But the plastic lens is quite challenging for the interchangeable lens because we use it in the field. So this lens must be usable from -20C to +45 or 50C. So the glass, the plastic is very weak for the temperature changes. Some liquid lens, we have been talking about the liquid lens for more than 20 years, but quite difficult to control the precision in the surface. So I think we stay on the classical methodology, but with new technology.
Okay. And there are technologies completely new. I heard about liquid lenses.
Yeah.
Do you think they can be in the future used, and where? I suppose not in camera lenses. Where do you think this technology could be interesting?
Yeah, I mentioned about the liquid lens, and it's quite interesting technology. It's been quite interesting for many years, but it's quite. There are many challenges to be solved, to be addressed. So, in order to use in such a high quality products, I think we need a time. But such a technology could be usable for some different kind of devices, like a smartphone or entry class digital camera. This is my belief that such a new technology always start from the how to say, not super high quality product, but the new devices which can take the risk. Such the advanced new devices can take the risk. So they may start using such a technology, and if they use it for the mass production, the technology get matured to be usable for the high-end products like this. So probably the high quality product is the last device to use such a new technology. That's my understanding.
And about smartphone, do you think that image quality can be increased because there is the great problem with smartphone that you must use a very small sensor because it's too flat. You have the problem of the lens that must be short. So, do you think possible to have a quality, higher quality than the actual with smartphone?
Yes, I think so. The image quality would be better and better, but in different way. maybe, of course, each device is like a lens or sensor will be better, but also thanks to the image processing. Now many engineers working on that segment, so I think the image quality will be good thanks to such kind of peripheral technologies, including the image processing, I mean the image collection. But I think their improvement going to a little bit different direction from the high-end camera, because smartphone is mainly used for the communication, like posting image on social media or communicating with friends, take pictures and send emails with pictures, and I'm enjoying the aperitivo in the garden, something like that. So the picture taken with the smartphone is mainly used for the communication. So image quality of the smartphone will be improved for that direction, best suitable for the communication. Not too much data, the better impression on the small screen, not too much details. But when it comes to the high-end products like a DSLR or the compact mirrorless camera, it's photography. We enlarge the picture on monitor, we print in the big printer, and we look at the picture from center to corner, we look at the details and the shadow and the gradation. It's different. We have many different points to evaluate the pictures. Looking at the picture in the small, now it's actually the LCD of the smartphone is getting bigger, but still small compared to the photography. So the goal is a little bit different. So I would say, I would answer to your question, yes, the image quality will be better, but the direction will be a bit different.
What about Foveon?
Yes.
You bought Foveon in
2008.
Okay. And there are important elements in this technology that can help to produce better images. You don't have to interpolate. Pixel interpolation is a big problem.
Yes.
To have good images. You have no aliasing, chromatic aliasing. You still have aliasing, but not chromatic. That is dangerous. And probably you have better sensitivity. Or not?
Yeah, as a sensor, better sensitivity. But when it comes to image quality, it's not. But yes,
and
because we do not have a cutting filters. Color filter cuts the light, but we don't have that color.
Okay. And what about color reproduction? Can you control the band of a frequency to have a photopic rendering, to have a response similar to of the eye? It's quite simple if you use a Bayer matrix. So you decide, I use this red filter, this green filter, this blue filter. But with your technology, it seems quite difficult to have a precise rendering of the color like eye.
Well, actually, the response of the eye, human eye, is quite similar to Foveon sensor. Foveon sensor have a many crosstalk for actually we call it BGR, but actually it's each channel has a much crosstalk. So it's not the pure blue, pure green, pure red. It's much crosstalk. And likewise, human eye have a similar spectral response sensitivity. They don't call it blue or red. They call it short, medium, and long, and many crosstalk. So as a capture devices, foveon sensor and the human eyes very similar each other. And this overlapped, actually this is quite challenging for image processing, but this overlap version portion or crosstalk is workable for the very precise gradation of the color, because we can capture all the color, not just pure blue, pure green, pure red. The Bayer sensor missed some crossing point, but of course Bayer sensor also some crosstalk, but the majority of the crossing point are lost. So as a capture device, very similar to human being, but after the awards, image processing is different. So yes, we have a challenge to create images like traditional photography. It's quite, it requires a unique technology. And actually, the image processing for the Bayer sensor is quite standard, and everybody uses almost the same technology for many, many years. So they can benefit from the heritage of the image processing industry. But foveon sensor is, the spectral response is so different, so we have to develop our own methodology by ourselves.
And in the future, you think possible to have a larger foveon, to a full frame foveon, or higher resolution? I don't know.
Many customers ask the same question to us, and I cannot comment on it because it connects to the future products. So, but in my opinion, the crop sensor like APS-C has also have an advantage because if you use the lens for the full frame, you can use the best part of the lens. So you can expect a very high quality from center to corner. This is very important point to have a perception of the real great picture. For example, our DP camera have such performance. The lens for each DP has a very good performance from center to corner, so you can enjoy the very good image quality from center to corner. But when it comes to full frame, quite challenging to implement the good image quality from center to corner. So I think the crop sensor also has the advantage.
Surely, but full frame sensor has advantages to control the focus. It's for high level photographers. This is really important. So full frame is
yes.
requested.
Yes, I understand, and also I like the pictures taken with medium format film or even 8x10 film. When I saw the picture taken with 8x10 film, I was really, really amazed and very surprised by the quality. So one of my dream is to create a picture quality like the one taken with 8x10 film. So I understand that the larger sensor has a significant advantage.
So for the future?
No comment.
And about resolution, I've seen that with the Quattro, you have a higher resolution on the BlueLabia.
Yes.
Why only in the BlueLabia and not in all the 3 layers? Why you decided that?
Yep. So for quad sensor, we call it 114 structure. 114 is RGB is 11, and the B is 4 pixels. And in contrast to that way, we call the conventional X3 layer as 111 structure. RGB is 111. So 111 is very simple, very original for X3 technology, but it has some disadvantage. If we are to increase the pixel count, the data amount of data get bigger and bigger. Actually, it's 3 times bigger than the pixel location, and in this case, read out speed gets slower, processing times get longer, recording times get longer. It's in case of raw files, it's quite challenging, and also wiring in the inside of the pixels quite complicated. But thanks to the 114 structure, we can simplify the pixel structure, and we can have a lighter data readout. But each pixel located in the same location, actually the BlueLabia can capture the exact same location of the data of the light go through. So it's not an interpolation. In case of Bayer, the light captured in a different location, say they have to mix up. But in our case, the light goes through, and each pixel located in each pixel location. So it's not a Bayer color interpolation. But afterwards, in the image processing, we can how to say, upsampling the color data with using the top layers data. So we can get equal quality as 114 structure. So there are many advantages in this pixel structure.
Last question. How much important is Europe and Italy especially in your market?
Europe as a whole is very, very important for us, first of all, of course, because as Europe is the biggest market for Sigma, bigger than North America, bigger than Asia. So Europe is most important. Also, it's my understanding that the people in Europe appreciate the quality. They like the high quality products. So the being accepted by the European market is quite important for us. Italy is also a very important market because the people like photography and people care about the quality, and people appreciate our direction. So the Italian market is very important, and also I personally love Italy very much. I like Italian wine, Italian food, Italian clothes. So I'm pretty happy doing business thanks to the collaboration with M Trading for a long time in Italy. And my dream is to be accepted even better by Italian customers.
Okay, thank you very much for the time you spent with us and for your answers. Thank you very much.
Thank you very much. I appreciate it.